Right, we're carrying on with this. Right, so you've got here metal. This is actually quite a good question because it's allowing you to look at different types of reaction. So what's the first one? You combust it in air. So have you noticed that it burns with gas G? And when you've got combustion in air, you think of oxygen. Right, you're going to get magnesium oxide. Right, if you add this acid, hydrochloric acid, it's going to be a MASH reaction. So you've got a metal, which is magnesium, plus they've said hydrochloric acid gives water, and it'll be magnesium chloride. So what I'm going to do is I'm going to go down here, magnesium chloride. Right, I know chlorine -1, I know magnesium +2, because these two are not the same size. That's a 1, you cross over. So you end up with Mg1Cl2, but like we said, you do not need to write Mg1, you just write MgCl2, magnesium chloride, right? And then if we balance it up, we get 2 of them. We've got 2 hydrogens, 1 magnesium, that balances out. Right, magnesium with another acid, and it gives sulfate. So there's a clue in that. So there's 3 acids that you should know. So it's hydrochloric, and nitric, HNO3, and sulfuric, H2SO4. You have to know these. Just fact recall, just off top of your head. So sulfate, so there's a clue there that we're going to add acid, the sulfate, hydrochloric acid, sulfuric acid, hydrochloric acid. And then if you react magnesium using steam, not oh, there's no water here. Right, you're going to get magnesium oxide and hydrogen. Thereafter, F is solution, F is magnesium chloride. We've already said that. Gas G, where's gas G? Oh yeah, okay, we said oxygen. And sulfuric acid, we figured that one out. It was sulfuric acid. Sulfuric acid. Right. Between magnesium and steam. So we know you've got magnesium. You've got steam in the form of water, and you're gonna get they said, what did they say? They said hydrogen here. So that's a clue. Magnesium oxide and hydrogen. And magnesium oxide, I'm gonna put MgO. I'm gonna go over here, and you're gonna try it first. So what do we do first? We know magnesium's in group 2, it's gonna form a 2+, and oxygen forms a 2-. These two are both 2, so we can ignore them. So it's MgO. There you go. Right, let's keep going. The next question. Right, we're on this last question. Student uses apparatus to investigate temperature change when metals are added to dilute sulfuric acid. That's your thermometer. That's your beaker. That's your spoon or spatula. That's your metal. Right, so what they've done is they've used 5 different metals: aluminium, copper, iron, magnesium, zinc. What I'm going to do is I'm going to go through the reactivity series again. I know it's boring, but it's got to be done. Right, please stop losing careless marks always. And then what I do is I just say chicken in my head. Leave a gap and put chicken. And then you've got Zu is or zinc, iron. And then you've got copper, silver, gold. Yeah. What do they call them? Jewelry metals. Some kids were saying that they're called jewelry metals, or the teacher taught them that, which is fair enough. I think of them as Olympic medals. You've got silver, you've got gold, and then you've got bronze, but we don't have bronze, so we've got copper. Right, reactivity goes down, so it decreases as you go down. And these two are reference points here. They're non-metals. Right, so we need to read these temperatures, and it's not as easy as it looks sometimes. You've got to be careful, yeah, because I've seen them, they want half a degree as well, so that's 40, 41, 42, 43, 44, 45. Just always make sure. So we know that is 42 degrees. That one's 25, that one's 29. Now you've got to be careful with this. Look, 45, 46, 47, but if you notice, it's in between. Let me use another. It's in between. So they're expecting 46.5, 46.5. And this one they're expecting 30, 31, 32, and it's halfway along. 31.5. Right, that's what you're expecting. Right. Which metal produces largest temperature rise? So it will be magnesium. This one here. Okay. Magnesium. Explain the result obtained with copper. So copper does not react with dilute sulfuric acid. The same amount of magnesium added to 50 centimeter cubed. Explain the effect this would have on the temperature. So what's happened is they've only added, right, they've only added 25 centimeter cubed. If you add more, right, this is, right, let me just write this down. You would expect a lower temperature change because larger volume of acid to heat or to warm up. Yeah, so what it is, look, this is what they're trying to say to you. You've got two beakers. This beaker's got 20, 25, this beaker's got 50. You're using the same amount of energy there to heat this. This is gonna get hotter, this is gonna get warmer than this, because you've got, can you see, you've got the same amount of dots but they're spread out more, so you're gonna get a lower rise in temperature. That's what they're trying to say. Right, okay, let's go. Question 11. It's about hydrochloric acid, HCl, aqueous. Aqueous just means it's in water. Okay. Student observed reaction with 4 metals. Right, so let's go through that again. Please stop losing careless marks always. Chicken. Yeah. Zu is or yeah, and then you've got copper, silver, gold. The jewelry metals, yeah. Reactivity goes down. So this is the most reactive, and this is the least reactive. Right, so they've got 4 acids, very few bubbles, right, so look, very few bubbles is P, S, so them two are gone. Many bubbles quickly, many bubbles quickly, many bubbles very quickly, so that's the most reactive. And then you've got R, so it would be QRSP, that's fair enough. Give names of 2 products formed when magnesium reacts with hydrochloric acid. Right, okay. Remember what we said. Magnesium plus hydrochloric acid. It's a mash. So you've got salt plus hydrogen. And you're going to get magnesium chloride. I'm going to go here again. Magnesium chloride. I know that's a -1 and this is a +2. So because them 2 signs, there's a 1 there. Them 2 are not the same. We swap them over. It becomes Mg1Cl2. We do not need to write this one. So our answer is MgCl2. Okay, so MgCl2. So can you see that? So our 2 products is magnesium chloride. Yeah, or you can put magnesium. No, we're saying names. Chloride, so you can't write the chemical formula. And the other one, hydrogen. Describe a test to show a dilute acid contains chloride. Okay. What's the test for chloride as you add silver nitrate? Right, just bear with me 1 second. Right, I just wanted to check this, so let's be super careful. So what we'll do is we'll add dilute nitric acid, then add silver nitrate, and you're going to end up with a white precipitate. Right, so remember you've got a white ice cream with a hint of lemon. So this is how I like to see it, yeah. So that's your white ice cream, there's your cone, and there's a bit of lemon inside there. So white ice cream with a hint of lemon, so that's going to be yellow. So we're expecting chloride ion, so we're expecting chlorine, bromine, and iodine. So the way I remember it is, let me get this. If you look at your periodic table, halogens, fluorine, chlorine, bromine, and iodine. I always think this is way too reactive for the lab, too dangerous. So you're going to end up with these 3, and they're the 3 that I'm going to give you the color. Right, let's crack on. Question number 12. You've got magnesium, you add an acid, so this is a mash reaction. So you're expecting hydrogen, salt, acid, metal. So we're expecting hydrogen. So hydrogen is burning. Yeah, they said that. It burns in, it combusts in air. So we're expecting it to burn with oxygen. So when you got hydrogen combusting with air, we're expecting water there. And you put it on ice. And when you put it on ice, it condenses and it becomes, so these are droplets of water. And you've got anhydrous copper 2 sulfate, which is white. And when you put water on it, what happens is it turns blue. So it's hydrated. Say one precaution that students should take after adding dilute sulfuric acid before lighting the unreacted hydrogen gas. What you do is you would let it, you've got air in here, oxygen, yeah, you've got oxygen in here. What's going to happen is if you try to ignite it, it will just explode. So you wait a bit, let all the air, in particular the oxygen, purge out, and then you light it. So you wait until all air is flushed through, and then because to stop an explosion. State 2 observations. Right, standard reaction. Right, remember it's a MASH reaction, so we're expecting S and H. H tells you what you're going to observe. You're going to end up observing what? Effervescence. Right, and the metal gets smaller. Or you can say, if it's a complete full reaction, it will disappear. Step 1 observation, when hydrogen passed overheated copper to oxide. So what's going to happen is you have to know that copper to oxide is black. When you heat copper to oxide and you pass hydrogen over it, what's going to happen is the hydrogen and oxygen will no, what'll happen? Right. What's going to happen is, let me get this right. What's going to happen is you're going to end up with copper metal because the oxide is going to disappear with the hydrogen. So you're going to just end up with a pink, well, I call it pink metal, but they allow orange, pink, or brown. So whatever color you want to call that. So that's all they're saying. You'll end up with a pink. It'll go from black to pink. Right. So what did we say about copper 2 sulfate? So remember what we said? We said anhydrous, no water is what color? And when you hydrate and you add water, it becomes blue. So it will be blue. Complete the word equation. So magnesium sulfuric acid gives magnesium sulfate. So remember, you've got to be careful you don't mess up. It's a MASH reaction, so we're expecting hydrogen. Copper 2 oxide and hydrogen will give copper and water. Anhydrous copper 2 sulfate plus water gives hydrated. So you've got to use the word hydrated. Hydrated copper. Don't write just copper sulfate. Try to write copper 2 sulfate to be sure of the mark. Right? A sample of sulfur is burned in a jar. Gas in a jar. Oxygen. A damp piece of litmus paper is placed in the jar. The litmus paper changes color. So you've got sulfur plus oxygen gives sulfur dioxide. Sulfur dioxide plus water will give sulfuric or sulfurous acid, yeah? Sulfuric or sulfurous acid. Right, I've seen this on the mark scheme, especially with acid rain. And under certain conditions, you can end up with sulfuric acid. But what they do is they allow... yeah, okay. I think they'll allow both. So explain what this color change shows about the acid-base character of the oxide. So you've got damp, remember they put in damp litmus paper and it turned, I know it doesn't actually, don't tell you. So it's turned red, so the litmus turns red. What does that mean? Since sulfur dioxide is acidic in nature. Okay, the formula of two oxides at MgOs suggests a formula. Okay, so you've got magnesium oxide plus sulfur dioxide. So you're gonna end up with magnesium sulfate. Magnesium sulfate. Suggest the formula. Okay, so they want this bit. It's a 1 marker. Right, let's have a look. What's next? No, let's keep going. It's nearly done this. Sulfur gained oxygen. Yeah. Identify the ion that causes the solution to be acidic. The ion that causes its H plus ion. So remember we've said the hydrogen ion makes something acidic, and the hydroxide ion makes something alkali in nature, and this is acidic. State how the litmus paper can be used to show that the solution is acidic. It will turn red. So damp blue litmus paper turns red. Right, again, it's a standard answer. Magnesium ribbon added to acid, you're going to expect what? Resins. And what else are we expecting? The magnesium metal, magnesium ribbon or metal disappears or gets smaller. Disappears. I think it's best to put disappears, because if you've got excess acid, you're going to get that. Right, so what we're going to do is we're going to call it quits at that, and maybe attempt another video